Wonderful. Thanks for coming to my talk today. A lot of great options. Thanks for choosing mine. We're going to talk today about what it's really like to run Cloud Foundry, or any distributed system really, at scale. A lot of times when you get to these presentations, everybody is very excited. They give their great success stories. Everything seems so wonderful and life-changing and money-saving and profit-generating. And I bet a lot of the people in the audience don't feel so great because they think to themselves, well, it's not easy for me. It's not easy for them either. We're going to show you that there are a lot of really common pitfalls along the way, and maybe you'll be able to avoid them. Maybe we're just going to teach you how to handle them straight on. Normally this is the part where folks do introductions. My bio is on the SCED site. You can read it. I'm an advisory solutions architect with Pivotal. Been with them for about 2.5 years. I would like to give some special credit right now to my friend and colleague Stephanie Mathis. Could not be here today. She helped me write this talk. We presented it together at the CF Summit in Philadelphia earlier this year. That one's available on YouTube. Highly suggest you watch both versions. We have to condense this one into a 30-minute version. The one we did in Philly was an hour-long version and has even more good tidbits in it. So the idea being, we have these things that happen to all of us. And we have, I think I have 5 or 6 in this iteration of the talk that we're going to talk about as things that you're going to do, things that you're going to run into that are can be problematic, and how we can help fix them. So let's dive right in. So the first thing that we always think of is that automation is the solution to every problem we have. It can also cause some of those problems. I want you to think about sometime, how many in here are developers or have a development background? Okay. How many of you have started working on a piece of code and did not want to release it until it was perfect, until it had every bug fixed that you could find, until it did everything you wanted, and even some of the stuff you didn't necessarily want to do yet but was going to do in the future? That is a really common paradigm, and obviously it's something we need to fight. Because perfect is the enemy of good. If you're shooting for perfect, you can never release good, and that's a real problem. So we're going to wear a couple of different hats throughout the course of this talk. So first thing I want you to put on is your painter's hat. And I want you to meet a friend of mine. And his name is Bob Ross. How many in here know Bob Ross? Everybody know Bob? If you don't know Bob, he had an American TV show called The Joy of Painting that ran for about 40-ish years. And every week when he did his show, in the course of 22 minutes, he completed, start to finish, a painting. And it's a nice painting. If you watch the show a lot, like I did, you start to notice patterns. There's always mountains. There's always trees. They're good paintings. They're not perfect paintings, but he put out a new one every week. And now I want you to think of someone who is a very special guest, because we are in the Netherlands, and his name is Rembrandt. This is his 350th birthday this year. Happy birthday, Rembrandt. One of his most famous paintings is called The Night's Watch. And it took 3 years between when it was commissioned and when it was finished. Now, you look at that, and subjectively, at least to me, that is a nicer painting than Bob Ross had. And it took 3 years. Yes, it was more complex. It needed 3 years, but it took 3 years. Think of how many paintings Bob did in those 3 years. It's like 160 paintings. And Rembrandt did one. It's nice, but in that whole time, if you wanted to collect paintings, you got one versus the other person who has 160. Now, this seems like a weird tangent, and it kind of is. But it's because we don't want to wait until things are perfect to get them out there. At Pivotal and at a lot of companies, we practice iterative development. We work on code. We release it. We release it early. Sometimes we release it uncomfortably early. We want to be a little uncomfortable the first time that code goes out. And then we validate what we hypothesized when we put this code together. Or we validate that it was untrue. And then we go back and we do this whole process again until we have a great product that's ready for folks to use. And that's why, it sounds like a weird tangent again, but the whole point is get your stuff out quickly. Automate what you need to automate. Don't automate for every edge case immediately. Add those edge cases in when they come in. The next thing, and I bet a lot of the folks in this room have had to answer this question when you're in a meeting with your boss and your boss says, I need to know everything that could go wrong. How many folks have had that conversation? Even though it is a literally impossible question to answer. Because you don't know everything that could go wrong. It's unexpected. You can't actually expect the unexpected because then it would be expected. But those same folks that raise their hands, actually for everybody, have you ever dealt with a situation where you wanted to try something in your production environment or even a non-production environment, and you were concerned that if you took a risk and it didn't work out, that you were going to be punished somehow? You would, you'd lose access to prod, or you would be taken off the project, or worse. That is not something that it's obviously a toxic thing, but it happens. So let's take that to another extreme. What happens if your entire production foundation goes down? Maybe you had a misconfiguration in your platform. Maybe someone had a typo in a JSON file and AWS loses a whole region. That has literally happened. What do you do in that case? Do you have failover? Do you have disaster recovery plans in place? You need to be prepared for those things. Because we don't want to expect the unexpected. We can't. But we can plan for the unexpected. Once these things happen, how do you react? That's what's really important. How do you react to a failure? How do you do a post-mortem? A poll for the audience. How many here do post-mortems? That is a much higher number than I expected, so that's awesome. Now, when you do a post-mortem, who here focuses on who did something wrong? Oh my God, there's 0 hands. I'm so happy. And how many here focus on what went wrong or why it went wrong? Good, because those two options, they are not equally valid. That is not a, hey, you can do this or this. No, don't ever ask who. The Google SRE book explicitly calls out blameless postmortems, and that's what we're talking about here. We don't care who did something, maybe unless they did it maliciously, but we care why it was done. We care what happened. We care how to fix it. So when you do your postmortems, be thorough, come up with a good answer as best you can, with no blame assigned, and then you publicize that. You be transparent. Because when you're transparent with your failures, you can then advertise your successes, and people will take that a lot more seriously. And you should advertise your successes because you need buy-in. So, along that line, let's talk about one of the hardest things in distributed software, and that's upgrades. And it's not just a technical problem. In fact, I would argue that the technical problem around upgrades is the easiest part of the problem to solve. I would suggest that it's a culture thing. So I'm going to ask the audience again. You have a site that you're running. It's an app running in production. You have How many of you have maintenance windows in which you're allowed to update your apps? Are you expected to have 100% uptime the rest of the time? No, some yes. There are some yeses, definitely. Well, here's the problem with that. When you are expecting 100% uptime, you are then expecting, by definition, static infrastructure. Static infrastructure sounds great. It doesn't change. It doesn't, it doesn't fail. It doesn't go down. Au contraire. Really what happens is, as security vulnerabilities come in, you are now exposed. As kernel bugs are found, you've been exposed, but now when people know how to reproduce it, you are more exposed. You need to learn to do small, incremental upgrades, because as you let that time between upgrades go, you have compounded your risk. And it's not a linear compounding thing. If you, the amount of risk that you have if you do 2 upgrades in a week, in a 7-day period, is a lot less. And it's not 4 times less, it's a lot less than if you wait a month between those 2 upgrades. Because, especially in an open source piece of software like Cloud Foundry, you may have 10 updates come in that month. You may have 20. And you can't always skip. Sometimes you can, but you can't always. And so you need to be able to do that. And you need to be able to do it during business hours. Because think about this. Let's say your maintenance window is once a month or once a quarter. And it's from 8 p.m. on Saturday to 8 a.m. on Sunday. That's all well and good. That's a pretty common practice. But now look at it from the consumer side. Let's say you went to your bank's website because you wanted to transfer some money. Or you went to an airline's website because you want to book a plane ticket to go on vacation. And the site was under maintenance. That's a pretty terrible user experience. So do it during business hours. Do it small, do it quickly, and do it seamlessly, which you can do with these big platforms like Cloud Foundry. You can do blue-green updates. You can have a rollback strategy. And it's a lot easier to roll back one app or, one component change than it is 50. After that, you also have to worry about how performant you are as a person, as an engineer. Let's think about a situation where you're on a bridge, it's a midnight on a Wednesday, and you're in your maintenance window and you're deploying an update, and something goes wrong, and you have to do some debugging. How many of you here think you are performing at your full potential at midnight on a Wednesday versus, say, 10 a.m. on a Thursday with your entire team around? It's a lot different when you have those resources available to you, people, knowledge bases, that sort of thing that you can just tap into immediately. That's another reason why business hour upgrades are great, because nobody gets tired. Nobody has to hold the pager. That's great. And nobody has to hold the pager for the upgrade. People still have to hold the pager occasionally. And so this next one that's coming up is something that we see a lot in my role as a solutions architect going from client to client. It is one of the biggest concerns that we hear from clients, which is, what if we just spent millions of dollars on hardware and licensing and this and that, and nobody wants to put their apps there? Now, certain companies can act very authoritarian in that regard. They'll say, well, you've got to put your apps there. But that is not what we're talking about here. We're talking about a relatively autonomous organization where you have some choices. So If you're all still wearing your painter hats, I hope you took them off. But take your painter hat off, put on your philosopher's hat, because I'm going to ask a really deep existential question, which is, if you've got a prod environment and it's not taking prod traffic, is it really prod? No, it's not. It's wasted hardware or wasted public cloud spend. You have got to get your apps on prod. The easiest way that I have found to do this is find yourself what we call a high-value app. It may not be the highest traffic app. It may not be the most business critical or the biggest revenue driver, but find one that's going to really exercise your platform and as many of its capabilities as you can, and partner with them. Get them to really buy into this and get them to push to prod quickly and frequently. And when that succeeds, I want you and that team to broadcast that to the rest of your IT org until they get annoyed with you. You need to be able to make other people want to join this party of running on Cloud Foundry. But every good party needs a doorman, because the other option is, what if you put all this money and time together and everybody shows up all at once and they immediately want to be on prod? That is not great either. You have situations where, let's say you're bringing in 100 apps and one of them pushes to prod and they're in debug mode. And it's a Spring Boot app. And there's a problem with that Spring Boot app. And it starts spitting out hundreds of exceptions. And let's say you're doing this in 5 instances. You are now dealing with tens of thousands of lines of log messages being spit to your log management system in a matter of seconds. I have seen this at a client where they literally brought down their Splunk infrastructure because they had a couple of crashing apps that were sending 10 million lines of logs a minute to Splunk. They were not prepared. Their Splunk team was not prepared. The Cloud Foundry team was not prepared. Clearly, the app developers were not prepared. So you need to be able to learn to scale. You need to learn how to effectively prepare your system, because maybe you don't even have the hardware to handle that. So that's why you bring teams on slowly, 2 or 3 at a time. Let them exercise the platform. Make sure that all of your capacity is holding up. Make sure that your observability is still there. None of your alerts are firing. There have been great talks this week on observability within the Cloud Foundry platform, and if you haven't seen them, check them out on YouTube when they're up in a week or so. Because you need to reduce that blast radius. You need to minimize it. Because if something goes really wrong and you went from 1 app last week to 150 apps this week, that debugging might be harder. It'll probably be harder. So try not to open the floodgates all at once. And those are, your big technical concerns. Great. But I remain convinced that the hardest problem in computer science is not exactly once delivery or cache invalidation or naming things. It's people. So we should talk about how to build the perfect product team to run this platform. But a few minutes ago, I did say perfect was the enemy of good. And so maybe we should work on building a good platform, or a good product team. And yeah, I do mean product. There have been talks this week on running your platform as a product, having a strong internal brand, treating your developers like your customers because they are. You need to react to their needs. And don't worry, the customer isn't always right in this situation. It's not that, this isn't US retail. But you still have to be involved with them as a provider and them as a consumer. Your team needs engineers, obviously. As a Pivotal employee, I implore you to use pairs of engineers so that you have feedback loops and you get knowledge sharing. I think the pairing model is great. You need a product manager. Not necessarily a project manager or a program manager, but a product manager. One of our big differentials between product and project in this context is that, in my opinion, a project has an end date. A product does not. A product is done when the last user stops using it. And so you need to have that kind of mindset. Someone that's going to help keep the brand together, who's going to do your user interviews and really going to learn what your customers need. And maybe you need a designer. Designers are great. Designers are going to help keep your brand strong. We have a great collection of designers, and they do a lot of really great stuff for us and our customers. Maybe you have more. Maybe you have who here works for a company that has a manual QA org? Anybody? Anybody does manual testing still? Great. Bring testers into your team. They're going to be a vast help because they're going to think of things that you didn't. Maybe you have an actual marketing person that can be part of your org. That would be great too. It actually can be great because then you work together, the developers and the marketers, to really put out something that is flashy but also realistic. And more to the point, your app devs should be responsible for their own code. They should hold the pager for their apps. You should be involved, but they should also hold the pager. When app devs are on call for their apps, they feel pain if their app isn't written poorly, and it leads to better quality. And all right, who in here is a manager? All right, this is for you folks, specifically. When you've got someone on call and they're holding the pager, don't make them do backlog work the rest of the time when they're holding the pager. Let them work on experiments. I've held the pager before, and when I was not on call, during off hours, when I was in the office, I reduced tech debt. I went through and said, I have been meaning to do this for 2 months. It's going to make my life immeasurably easier. And I did that sort of thing. And not only did we get rid of a lot of tech debt, it actually reduced the number of pages I got. And that's really important because that keeps people happy. Pager burnout is a thing. And you've got to be wary of it. As an engineer, as a manager, you have to be aware of it. So again, this was an abbreviated version of this talk. There were some great things that I had to leave out, unfortunately, and we are just about out of time. I'm not going to do Q&A in here, but I will be around all afternoon. I'm not inconspicuous. I'm easy to see and find. So please feel free to grab me in the hallway. If you have any questions, you can find me on Twitter or GitHub as well. So thank you very much for listening to me tell dumb jokes.